This is Gagan Girotra, IIT Roorkee class of 2000, and I am Calcutta class of 2005. This video will cover exercises on arithmetic progression and geometric progression. So let's read this first question. This says the 7th and the 22nd terms of an arithmetic progression are 6 and -24 respectively. We are required to find the 51st term. So the 7th term, we know that nth term is given by a plus n minus 1d. So the 7th term, which is 6, will be equal to a plus 7 minus 1, 6d. Now the 22nd term similarly is given to us is -24. So -24 will be a plus 22 minus 1, 21d, right? So from their difference, now we get two linear equations and we have two unknowns. We can solve these linear equations to find the values of a and d. So when we subtract the first equation from the second equation, right, we get a cancels a. 21d minus 6d will give us 15d. So on the right hand side we are left with 15d. On the left hand side we have minus 24 minus 6 equals minus 30, right? So we straight away get d equals -2. Now we can put this in this equation to solve for a. This will give us a equals 6 minus 6d, right? So when we put the value of d as -2, we get 6 minus 6 times -2. So this becomes 6 plus 12, 18. So now if we are required to find 51st term, we have a and we have d. So the 51st term is going to be a plus 51 minus 1, 50d, which equals 18 plus 50 times -2. So 18 minus 100 will give us -82. So that's the answer. Now in this question, it is given that the sum of first 4 terms of an arithmetic progression is 28. Sum of the first 8 terms of the same AP is 88. We need to find the sum of first 20 terms of this AP. Now the formula for sum of n terms of an AP is given as n by 2 times 2a plus n minus 1d, right? So we use this to calculate to get our first equation. Now 4 terms, the sum is 28, so we have 28 equals 4 by 2 times 2a plus 3d. 3 is 4 minus 1. Similarly from here we get 88 equals 8 by 2 times 2a plus 8 minus 1, 7d, right? So we just, let's simplify. So this is 2 and 14. This is 4 and 22, right? So from the first equation we get our first linear equation, 2a plus 3d equals 14. From the second sum we get 2a plus 7d equals 22. Now from both these equations, when we find the difference of both these equations, 2a and 2a will get cancelled. From 7d we subtract 3d to get 4d, and from 22 we subtract 14 to get 8. So we get d equals 8 by 4 or d equals 2, right? So we've solved for d. Now these are linear equations. We can figure out our second variable also. So from this equation, when we put the value of d as 2, we get 2a plus 3 times 2 equals 14. So we get 2a, this implies 2a equals 14 minus 6, 8, or a equals 4, right? So we found our second unknown also. Now we need to find the sum of first 20 terms. Now the sum of 20 terms is simply going to be, we'll use this formula, n by 2, which is 20 by 2 divided by 2a plus n, which is 20, n minus 1, which is 19. 19 times d, which is 2. So we get 10 This is 8 plus 19 to the 38. This is 10 times 46, so this equals 460. So B is the right answer. Now in this question it says we need to find the lowest number in an arithmetic progression such that the sum of all terms is 140 and the greatest of the terms is 6 times the smallest of the terms. So let's make our assumptions. So the assumptions are as follows. The first term of the arithmetic progression, let it be A. Number of terms of this arithmetic progression, let it be n. Common difference, let it be d. So the last term is going to be a plus n minus 1 d, right? So we've made these three assumptions here. Now since the sum of all the terms is 140, we'll use the formula for sum of an arithmetic progression. So 140 equals n by 2 times 2a plus n minus 1 d, right? So we'll just simply take 2 here at a later time when this will become 2a equals n times 2a plus n minus 1 d. Now what we do next is, what we've also been given is that the greatest of the terms, or the last term, which is a plus n minus 1 d, is 6 times the first term. So from there we get a plus n minus 1 d equals 6a. So when we take a to the right hand side, we get n minus 1 d equals 5a, right? So when we apply this to this equation, right, we apply this n minus 1 times d, we notice that we have an n minus 1 d here also. We apply it here, we get 140 equals n by 2. 2a will just simply replace n minus 1 d from here with 5a. Okay, so this again gives us 140. Now I'll take the 2 to the left hand side. We get 280 equals n times 2a plus 5a, 7a, and this 7 is going to cancel 280 to get 40. So what we've gotten from this equation is n times a equals 40. All right, now this is going to become a key discussion point going forward. Why? Because let's look at let's look at what possible values n can take. You would recall that n is the number of terms and n is always going to be a natural number. Also, since there is a lowest term and a largest term, right, and the lowest term is 1/6 of the largest term, so n must be a natural number whose minimum value is 2, right? Also, what we've known from this equation is that the product of n and a is always going to be 40. So let's look at the possible values of n and a. Now if I start with n equals 2, yeah, the a is going to be 40 divided by 2, 20. If I take my n as 3, my a is going to be 40 by 3. If I take n as 4, my a is going to be 10. If I take n as 5, the a is going to be 40 divided by 5, 8. If I take n as 6, my a is going to be 40 divided by 6. Right? So that's how this we can find all the possible values of a for all different possible values of n. Now out of these, I notice that I can see a 20 here in the answer choices. And can n be 20? The answer is yes, n can be 20. Oh sorry, can a be 20? The answer is yes, a can be 20. Can a be 10? The answer is yes, a can be 10 as well. Can a be 8? Yes, the answer is a can be 8 as well. So we'll just simply mark all the above as possible values of a. Now let's read the next question. It says, how many terms are identical in these two arithmetic progressions? The first one is 1, 3, 5 and so on, and it has 101 terms. The second one is another progression. It has the first term as 3, it goes on as 3, 6, 9, and this progression's got 67 terms. Now let's first see what these progressions really are. So the first progression is 1, 3, 5, 7. We notice that this is the series of odd numbers, so the common difference is 2. The first term is 1, right? So the 101th term is going to be A plus 101 minus 1, 100D, right? So this, the last term of this series is going to be 200 plus 1, 201. Okay, so this is how our series looks like. It has got A equals 1, D equals 2, N equals 101, and the last term as 201. Let's look at the second series. The second progression is all the multiples of 3, right? So the first number is 3 times 1, the second number is 3 times 2, the third number is 3 times 3, and so on. So the last number is simply going to be 3 times 67, which equals again 201. Right? So again we have an arithmetic progression whose A equals 3 and D also equals 3. Now in this case, if we have these two arithmetic progressions, we notice that the common terms are going to be all the odd multiples of 3, right? Because this series really is just all the odd numbers. This series is all the multiples of 3. So the terms which are going to be identical in both the APIs are going to be all the odd multiples of 3. So the new series is going to look like this. It's going to have 3 because 3 is here in both of them. Then it is going to have 9 because 9 is there in both of them. Then it's going to have 15, then 21, and so on, and it will go all the way to 201. Right? Now, if this new series is all the odd multiples of 3, then really what we get is another arithmetic progression whose first term is 3, whose common difference is 6, right? And whose last term, let's say nth term, is 201, right? What we need to do is we need to find the number of this term, right? What number term is this? If we have that number, we'll know how many numbers there would be in this series, right? Now 201 is going to be A plus n minus 1 D, right? So when we solve this, we get n minus 1 equals, we take 3 here, 201 minus 3, and we divide this by 6. So this is 198 by 6. So this is equal to 33. So if n minus 1 equals 33, then n will be equal to 34. So in the series that we get by picking out common numbers from both of these original series, there are 34 terms. Now let's look at this number, this question. It says a number 18 is divided into 3 parts and all of them are in an arithmetic progression. It is also given that the sum of their squares is 110. So what we need to do is we need to find the smallest of these 3 parts. So if all of these 3 numbers are in an arithmetic progression, right? Let's say these 3 numbers are A minus D, A, and A plus D. Now we know that their sum equals 18. So when we simplify, we get 3A equals 18, or A equals 18 by 3, 6. Now please note that what we have found really is the middle term. This time A is not the first term of this series, but A is this time the second term of this series. Okay, so the three numbers are going to be 6 minus D, 6, and 6 plus D. Now what is also given to us is that the sum of their squares is 110. So let's do that. So the square of 6 minus D plus the square of 6 plus the square of 6 plus d adds up to 110. So what we get here is 36a square plus b square minus 2 into 6 into d, which is 12d. Then we get 36 from here, and we get 36 plus d square plus 12d equals 110. Now when you look at these brackets, you notice that the negative 12d and the positive 12d will cancel each other. What we'll get is 36 plus 36 plus 36, 108. What we'll also get is d square plus d square, 2d square equals 110. So we'll continue here. So 2d square equals 110 minus 108, 2. So d square equals 1, or d equals positive or negative 1, right? So when we apply this d, we get the series to be 6 minus 1, 5. The middle number is 6, and 7. If you apply minus 1, you'll get the series 7, 6, 5, which practically means the same thing. Okay. Now what we need to do is we need to find the smallest of these three parts. The smallest of these three parts is 5. Now in this question, it is given to us that the sum of three numbers in GP is 21. So if these are A, AR and AR square, it is given that their sum is 21, right? So we'll just simply apply the calculation that we use for sum of a GP. So sum of these terms is given to us as 21, and the formula for sum is A into R to the power n, which is 3 here, minus 1 divided by R minus 1, right? So what is also given to us is that the sum of their squares is 189. Now if the original GP is AR square, the new GP is going to be A square AR whole square, which is A square R square, and AR square whole square A square R to the power 4. Now please notice that even this is a GP. Okay, so when you add three terms of a GP, you can still apply the same formula. This time, however, the sum is 189, so we get 189 equals the first term into the cube of the common ratio. R square whole cube is going to be R to the power 6 minus 1 divided by the common ratio, which is R square minus 1, right? So this is what we get. Now using these, now we notice that there's a lot of powers of R and A here, right? So we can simplify this by, let's say, dividing this by this, or the other way around. The only thing is we need to cancel out A. But to cancel out A, what we can do is we can square this before we divide. So let's square this. We get 21 square equals A square R cube minus 1 whole square divided by R minus 1 whole square, right? So this is the first term, and I've squared it. And let's divide this by the second term here. This is 189. We divide it by this term, we get A square R to the power 6 minus 1 divided by R square minus 1, right? So this is going to simplify things for us. Why? Because it's going to cancel A square and A square. So 21 square is 441. So 441 divided by 189 equals R cube minus 1 whole square, right? And R square minus 1, from which is the denominator of the denominator, goes up, R square minus 1, and then we have R to the power 6 minus 1, and the denominator of the numerator will come down, R minus 1 whole square. We get R minus 1 into R minus 1. Now you'll notice that R to the power 6 minus 1 is equal to R cube whole square minus 1 square. So we can simplify this to have R cube minus 1 into R cube plus 1. Now 1 r cube minus 1 is going to cancel with this one in the numerator. So we are going to get r cube minus 1 into r square minus 1, and what we'll be left with here is r cube plus 1 into, this is r minus 1 whole square. Alright, now we can also reduce r minus 1 from here, right? Because this is r minus 1 into r plus 1. So when we cancel this, we get r plus 1, right? Also, that's right. So what we get is 441 by 189 equals, now I'm going to expand r cube minus 1 as a cube minus b cube. I get r minus 1 into r square plus r plus 1 into this r plus 1 divided by r cube plus 1. We get r plus 1 into r square minus r plus 1 and this r minus 1. Again, quite a few things are going to cancel, right? So I'm left with this term, 441 upon 189 equals r square plus r plus 1 upon r square minus r plus 1. Now when I cross multiply and when I add these, I've done that separately on a paper, I get the quadratic equation 250. So from here I'm just simply going to write this. So 252 r square minus 630 r plus 252 equals 0. Now when I go to when I cancel some of the common factors out, the final equation I get is 2r square minus 5r plus 2 equals 0. And when I further simplify, I break up the middle term, and when I further simplify, I get the possible values of r as 2 or 1 by 2. Okay, so basically what I've done is I've simplified this complicated equation to find my values of r, which are 2 or half. Now when I apply this, because I already I can apply this to find the value of to find the value of a as well. Now what we know is that the sum of these three numbers is 21. So a being the first number plus a into r, let's take the first term as the ratio as 2. So 2a plus r square into a, which is 4a as 21, right? So when I solve this, I get 7a equals 21. I get a equals 3, right? So the series is going to be 3 times 2 6 times 2 12. Okay, you notice that when you add them up, you get the number 21, and when you add their squares, you get the number 189. We need to find the largest of these three numbers. The largest of these three numbers is 12. Now in the next question, it says the sum of the first and the third term of a GP is 40, and the sum of all the three terms, the first three terms, is 52, right? So what this statement straight away gives me is the second term, because the first term and the third term, they add up to 40, and if the first and the second and the third, they add up to 52, then the second term of the GP is going to be equal to 52 minus 40 equals 12, right? Now the first and the third term, they add up to 40, so that means actually the second term is going to be equal to a into r, if I assume the first term to be a and common ratio to be r. Now the first and the third term add up to 40. That tells me that a plus ar square, the first term and the third term, they add up to 40, and I know that a into r is 12, right? So what I get is a so what I get is if I take a common, 1 plus r square equals 40. Also if a into r is going to be equal to 12, then I also know that a is going to be equal to 12 by r, right? So what we get is 12 by r 1 plus r square equals 40. I take the r to this side. I can cancel common factors also. 4 3 the 4 10 the, so we get 3 plus 3r square on the left hand side, and r goes to the right hand side, equals 10r. So from all of this I get a simple quadratic equation: 3r square minus 10r plus 3 equals 0, right? So when I split the middle term into minus 9r and minus r, I get the following. So we take 3r common, and what we are left with is r minus 3. Then we take minus 1 common, and we get r equals 1 by 3 or 3. Now if I take r equals 1 by 3 and apply it to 12, the series is going to be or rather if I take r as 3, right, and I apply this, so I get two series. The first series is going to be, since the second term is 12, the first number could be 12 divided by 3, which is 4, right? Then the next number could be 12 times 3, 36, and so on. If I apply the other common ratio, the same thing could be 36, 12, 4, and so on, right? So actually both of these work, right? So our answer is going to be C. Now in this question, let's find the sum of all numbers between 10 and 50 which are not divisible by 7. Now in computing this, what we are going to do is, we are going to, what is going to be simpler for us is going to subtract the sums of two arithmetic progressions as follows. So the first AP is 10, 11, 12, and so on up to 50, right? From this sum, if I subtract the sum of the other arithmetic progression, which is all the multiples of 7, which is 14, 21, 28, 35, 42, and 49, right? So if from all of these numbers, if I subtract these, I'm going to get my answer. So the problem automatically breaks down into finding the sum of these two arithmetic progressions and then finding their differences. So this arithmetic progression has first term 10, common difference 1, and the number of terms. Now this is important, pay attention. The number of terms, when you count the number of consecutive numbers which don't start from 1, is the last number minus the first number plus 1. So we get 41. Okay, so the sum here of numbers from 10 to 50, including 10 and 50, is going to be 41 by 2, 2a plus n minus 1, 41 minus 1, 40d. So we get 41 by 2 times 20 plus 40, 60. So this is 30. So 1230. Okay, now let's find the sum of this series. Now this is again an arithmetic progression whose first term is 14, common difference is 7, the number of terms is 6, so the sum is going to be 6 by 2, 14 times 2, 2a plus n minus 1, 5d. So this is 3 times 28 plus 35. This is 3 times 63 or 189, right? So all you need to do is subtract 189 from 1230 to get the answer 1041. Okay. Now in this question, what it says is that there are 4 geometric means inserted between 1 by 8 and 128. We need to find the difference between the third and the fourth mean. So first let's find all the means. Now inserting means that you start with the first number and you end with the final number. Only thing is you are inserting 4 means in between them such that the whole series forms a geometric progression. So the first mean is going to be AR, because I've taken this as A. The second mean is going to be AR square. The third mean is going to be AR cube. The fourth mean is going to be AR to the power 4, and this 128, which is the last term, actually ends up becoming AR to the power 5, right? Now if in this geometric progression I've taken my A to be 1 by 8 and AR to the power 5 equals 128, then I can simply find AR to the power 5 equals 128, 1 by 8 A, which is A, R to the power 5 equals 128. So R to the power 5 equals 128 times 8. This is 2 to the power 7, this is 2 to the power 3, this is 2 to the power 10. So R equals 2 square or 4. Okay, so I've found my R. So actually what this tells me is straight away it gives me all the means. I can find out all the means now, but what I need to do is just to find the difference between the third and the fourth means. So the fourth mean, AR to the power 4 minus AR cube, this is what I need to find. So what I'll simply do is I'll take AR cube common, R minus 1, so we get A is 4, sorry, A is 1 by 8, R is 4 times R minus 1, which is 4 minus 1. So we get 4 for the 16 for the 64. So 8 is going to cancel 64 to give us another 8 times 4 minus 1, 3. So the answer is 24. Right, now this is an interesting question. It says that after striking the floor, a rubber ball rebounds 7/8 of the height from which it has fallen. Now now how this bouncing business starts is that this ball is thrown upwards, and the first time round it goes up 100 feet, right? So we need to find out the sum of all the distances that this ball has traveled. Clearly this is a question of finding the sum of a geometric progression where the common ratio is less than 1, right, which is 7 by 8, and we need to find the sum of these terms all the way to infinity. So let's draw this to understand this a little bit better. So let's say the first time around this ball is thrown up, okay, and it goes all the way 100 feet. Now what it does is it travels this 100 feet and then it comes down all the way 100 feet. Okay, so basically the ball has covered, in its first throw up, the ball has covered 200 feet. Now because it has fallen by 100 feet and it bounces back up, right, so it bounces back up to 7 by 8 of its previous height, which is 100, and it comes back down again the same distance. So this time around, after between the first bounce and the second bounce, the distance that the ball has covered is 200 into 7 by 8. Why 200? Because it has gone up by 100 into 7 by 8 and it has gone down by 100 into 7 by 8. When I add these two up, I get 200 times 7 by 8. Likewise, after the second bounce and before the third bounce, it travels 7 by 8 of the previous distance, right? So this time around the height that the distance that the ball covers again is going to be 200 into 7 by 8 times 7 by 8. So you notice that if I am required to add all of these up, right? So next one is going to be 7 by 8 of this. The next one is going to be 7 by 8 of this length. So basically I'm getting a geometric progression whose first term is 200 and whose common ratio is 7 by 8. 200 into 7 by 8 square, right, this term, and so on, right, all the way to infinite terms, right? So this is what I'm required. So we know that sum of an infinite series where common ratio is less than 1 is given to us as a upon 1 minus r. So in this case, A is simply 200 feet, R is 7 by 8, so we get 200 divided by 1 by 8, which is equal to 200 into 8, which is equal to 1600 feet, right? So this is going to be our answer.
Thanks for watching the video. You can give your feedback in the comments section below. Please click the like button if you thought the video was helpful. For lesson updates, you may subscribe to my YouTube channel People Plus, or you may read my blogs at peopleprep.com, or you can directly connect to us through our Facebook page @PeoplePlus, or you can email to me at gagan@peopleplus.com. Thank you.